Out there, in the vast expanse of the cosmos, lies a galaxy that defies expectations, a swirling masterpiece of stars, dust, and secrets waiting to be uncovered. The NGC 1300 galaxy isn't just another pinprick of light in the night sky. It's a barred spiral galaxy, a cosmic whirlpool stretching over 110,000 light-years, and within its arms, mysteries lurk that even the sharpest scientific minds can't fully explain. Imagine a place where the laws of physics seem to bend, where celestial oddities appear without warning, and where every observation leaves more questions than answers. That's NGC 1300, a galaxy that refuses to play by the rules. What if I told you that some of the most baffling phenomena in the known universe are hiding right here within this single galaxy? From rogue black holes wandering like cosmic ghosts to unexplained energy, surges that flicker like distant signals, NGC 1300 is a treasure trove of the bizarre. And today, we're diving deep into 30 of its strangest, most mind-bending enigmas. These aren't just quirks of nature, they're cosmic puzzles that could rewrite what we think we know about space itself. This isn't just a tour of far-off wonders, it's an invitation to explore the edges of understanding, because every strange flicker, every unexplained anomaly in NGC 1300 is a reminder that the universe is far weirder, far more unpredictable than we ever imagined. So buckle up, we're about to journey into one of the most mysterious galaxies out there, where the answers are scarce but the possibilities, they're endless. One of the most perplexing mysteries in NGC 1300 isn't what's there, it's what keeps vanishing. Astronomers have observed something they call the phantom spiral arms, ethereal structures that flicker in and out of existence like cosmic mirages. Normally, spiral galaxies have clearly defined arms, but NGC 1300 seems to play tricks on scientists by sprouting extra ones that aren't supposed to be there, only for them to fade away without explanation. These ghostly arms don't just defy expectations, they outright break them. Current models of galactic structure can't account for why these temporary arms form, let alone why they vanish so abruptly. Some researchers suspect dark matter could be the culprit, its invisible gravitational fingers pulling at the galaxy's gas and dust in ways we don't yet understand. Others theorize that hidden gravitational anomalies, perhaps unseen black holes or even exotic forms of matter, might be distorting the galaxy's shape like a funhouse mirror. But the real puzzle, these phantom arms aren't just optical illusions. Detailed observations show they contain real stars and gas, meaning whatever's creating them has enough power to rearrange entire sections of the galaxy, if only for a cosmic blink of an eye. It's as if NGC 1300 is drawing extra arms in the sky, only to erase them before we can fully grasp their purpose. The implications stretch far beyond this single galaxy. If we can unravel why these phantom arms exist, it could rewrite our understanding of how all spiral galaxies evolve. Are these fleeting structures common across the universe, hidden in plain sight? Or is NGC 1300 truly one of a kind, a cosmic rebel bending the rules of physics in ways we've yet to decode? One thing's certain, wherever these phantom arms come from, they're a reminder that even the most familiar shapes in space can still hold jaw-dropping surprises. At the heart of NGC 1300 lurks something even stranger, a supermassive black hole that refuses to behave. Unlike the predictable monsters at the centers of most galaxies, this one flickers like a dying light bulb, surging and fading in brightness at irregular intervals. Scientists call it the flickering black hole, and its erratic behavior defies every textbook model of how black holes should feed. Normally, supermassive black holes consume surrounding material in a steady, predictable rhythm. As gas and dust spiral inward, they heat up, creating a brilliant glow that astronomers can measure. But NGC 1300's black hole doesn't follow those rules. Instead of a constant beacon, it pulses unpredictably, sometimes dimming to near invisibility, other times flaring up so violently it outshines entire sections of the galaxy. These aren't minor fluctuations, we're talking brightness changes of hundreds of times in mere weeks, a cosmic light switch being flicked by an unseen hand. So what could possibly cause such wild swings? One leading theory suggests the black hole might be feeding in fits and starts, gulping down massive clumps of material in erratic bursts rather than a smooth stream. Imagine a fire hose that alternates between a trickle and a flood. That's how chaotic the inflow of matter might be here. Another idea points to external forces, like a hidden second black hole or a dense star cluster orbiting nearby, whose gravitational tugs could be disrupting the accretion disk like a stone skipping across a pond. But the most intriguing possibility, this flickering might be evidence of something even more exotic, a phenomenon called a failed jet. Some supermassive black holes shoot out powerful beams of energy, but what if NGC 1300 is sputtering, starting and stalling in a cosmic stutter? It would explain the irregular bursts as trapped magnetic fields snap and reconnect in fits of violent energy release. What makes this flickering enigma so important is that it challenges our fundamental understanding of black hole behavior. If such extreme variability can happen here, how many other galaxies might host similarly unpredictable monsters? NGC 1300's restless heart isn't just a curiosity, it could rewrite the rules of galactic physics. And until we solve its riddles, every flicker remains a cosmic whisper, hinting at secrets we've only begun to uncover. Deep within the swirling arms of NGC 1300, astronomers have picked up something that shouldn't be there, a series of ghostly radio signals pulsing through the void with no clear cosmic source. These aren't the usual bursts from dying stars or colliding black holes. They're structured, repeating, and eerily out of place, like a whisper in a language we've never heard before. The signals defy every known category of celestial radio emission, leaving scientists scrambling for answers. Could this be evidence of exotic physics at play, or is there an even more tantalizing possibility lurking in the data? What makes these transmissions so baffling is their peculiar rhythm. Unlike natural cosmic radio sources, which tend to follow predictable patterns or chaotic noise, these pulses arrive in sequences that almost resemble a coded message, a signature too orderly to dismiss as mere cosmic static. Some researchers suggest they might stem from a phenomenon we've yet to discover, like magnetars with unprecedented magnetic fields or bizarre interactions between dark matter and interstellar gas. Others propose they could be the echoes of a cataclysmic event, a shockwave rippling through the galaxy's magnetic fabric in ways we've never witnessed. But then there's the elephant in the room, the unspoken question that sends shivers down the spines of astronomers. Could these signals, however faint, be artificial in origin? The idea isn't as far-fetched as it sounds. NGC 1300 is old enough to host civilizations that might have risen and fallen billions of years before Earth even formed. If just one of them reached a technological zenith, their transmissions could still be drifting through the cosmos, diluted by time but detectable as anomalies in our telescopes. Of course, extraordinary claims require extraordinary proof, and no one's jumping to conclusions. The more likely explanation lies in the realm of extreme astrophysics, perhaps a new class of quasar or a previously unknown interaction between cosmic rays and magnetic fields. Yet the mystery persists because every time scientists rule out one explanation, the signals stubbornly refuse to fit neatly into another. What's undeniable is that these ghostly radio waves are rewriting the playbook on what we thought was possible in deep space. Whether they're the product of natural phenomena beyond our current understanding or something even more profound, they serve as a humbling reminder. The universe is vast, strange, and far from finished surprising us. And until we solve this cosmic riddle, NGC 1300's enigmatic whispers will keep us listening and wondering. If there's one thing astronomers expect from star clusters, it's stability. These dense collections of stars, bound together by gravity, are supposed to be cosmic fixtures lasting for billions of years as they slowly evolve. But in NGC 1300, something bizarre is happening. Entire star clusters are vanishing without a trace, disappearing from telescope views as if they were never there at all. These aren't just dimming stars or obscured clusters. They're complete, unexplained absences, leaving behind nothing but empty patches of space where vibrant stellar families once thrived. The first clues came when researchers compared older observations with newer ones, only to find that several known clusters had simply gone. No explosive remnants, no scattered debris, no telltale signs of a violent end. It's as if someone flipped a switch and erased them from existence. The most unsettling part, these vanishing acts don't follow any predictable pattern. Some clusters fade over decades, while others blink out almost overnight, at least in cosmic terms. So what could possibly make entire star clusters disappear so abruptly? One leading theory points to an unseen cosmic predator, an intermediate mass black hole lurking in the galaxy's spiral arms. Unlike their supermassive cousins at galactic centers, these mid-sized black holes are nomadic, drifting through star clusters and devouring them from within. As stars get too close, they're torn apart in a process called tidal disruption, leaving behind no visible wreckage. If such a black hole were on the move in NGC 1300, it could explain the cluster's ghostly disappearances. But there's another, even stranger possibility: rapid stellar evolution gone wrong. Normally, stars in clusters age at a predictable pace, but under extreme conditions, like an unexpected surge in dark matter density, their lifespans could accelerate dramatically. Imagine a cluster where stars burn through their fuel in mere millions of years instead of billions, collapsing into black holes or neutron stars before they have time to disperse naturally. The result, a cluster that essentially evaporates, leaving behind only dark remnants too faint to detect. Then there's the wildcard explanation, something entirely new. Could these clusters be unraveling due to an unknown interaction with dark energy, or even evidence of exotic physics at play? NGC 1300's environment is unlike any other, with gravitational anomalies and magnetic fields that defy conventional models. If conditions there are warping space-time in unexpected ways, maybe these clusters aren't vanishing at all, but slipping into dimensions we can't observe. Whatever the truth, these disappearances are more than just a cosmic curiosity. They challenge our understanding of how star clusters live and die, forcing us to reconsider what we thought we knew about stellar longevity. And until we solve this mystery, every star cluster in NGC 1300 remains under suspicion, because in this galaxy, even the most predictable structures might just be temporary. Among the many oddities of NGC 1300, few are as mesmerizing as the phenomenon astronomers have dubbed the cosmic echo, a series of ghostly, repeating light patterns that ripple through the galaxy like reflections in a darkened mirror. These aren't fleeting bursts or random flashes. They're precise, rhythmic reverberations of light, appearing long after the initial event that triggered them, as if the galaxy itself is whispering back into the void. The first recorded echo confounded researchers when it appeared exactly where a supernova had erupted decades earlier. But instead of fading into obscurity, the light from that explosion seemed to bounce back, reappearing in the same spot with eerie regularity. Even stranger, these echoes don't match the expected behavior of supernova remnants, which typically fade or scatter. These pulses arrive like clockwork, their timing and intensity defying conventional models of stellar death. So what could be causing this celestial déjà vu? One explanation points to vast clouds of interstellar dust acting like cosmic mirrors. When a supernova's light blast slams into these dense pockets, it scatters in multiple directions, with some rays taking longer paths to reach us. The result, a delayed replay of the original explosion, staggered across years or even centuries. It's the universe's version of shouting into a canyon and hearing your voice return, except here, the canyon is light years wide, and the echoes are woven into the fabric of space itself. But there's a twist. Some of these echoes don't align with any known supernova. That's led to a wilder theory: gravitational lensing on an unprecedented scale. Normally, lensing occurs when massive objects warp space-time, bending light around them. But in NGC 1300, astronomers speculate that rogue structures, perhaps dark matter filaments or wandering black holes, could be twisting light into loops, creating multiple copies of the same event that arrive at different times. Imagine a hall of mirrors where every reflection is real, just stretched across decades of observation. The most unsettling possibility, though, is that these echoes aren't echoes at all. Some researchers suggest they might be evidence of something far more exotic: recurrent stellar explosions where a dying star doesn't just go supernova once, but undergoes repeated programmed detonations. If true, it would rewrite our understanding of how stars die and suggest there are forms of stellar physics we've yet to dream of. For now, the cosmic echo remains one of NGC 1300's most poetic mysteries. Whether it's dust, gravity, or something beyond our current science, these ripples of light remind us that even in the vast silence of space, no event ever truly disappears. It just waits patiently, persistently, to be heard again. One of the most unsettling discoveries in NGC 1300 isn't something astronomers saw, it's what they didn't see. Scattered across its spiral arms are vast regions where dark matter, the invisible glue holding galaxies together, seems to have vanished. These cosmic blind spots defy every expectation, because if there's one thing scientists thought they knew, it's that dark matter is everywhere, weaving its gravitational web through the universe. Yet here, in this peculiar galaxy, entire swaths of space operate as if this mysterious substance has simply packed up and left. The first clues emerged when researchers mapped the galaxy's gravity. Stars and gas at the edges of these anomalous zones moved too fast to be held by visible matter alone, yet too slow for the expected dark matter halo. It's as if someone took a cosmic eraser and scrubbed out patches of the galaxy's hidden scaffolding. Even stranger, these voids aren't random. They cluster in distinct geometric patterns, almost like dark matter is pooling away from certain areas like water avoiding a drain. So what could cause dark matter, a substance that supposedly makes up 85% of the universe's mass, to abandon ship? One radical theory suggests these might be collision sites with unseen structures, where dark matter particles annihilated each other in violent interactions we've yet to observe. Picture two invisible tsunamis crashing in deep space, their impact scattering dark matter like debris. Another idea points to rogue gravitational waves from ancient black hole mergers, rippling through the galaxy and literally pushing dark matter out of alignment. But the most provocative explanation: dark matter might not be missing at all. It could be evolving. Most models assume dark matter is cold, slow-moving and clumpy, but these anomalies hint at something more dynamic. Imagine if dark matter in NGC 1300 has properties we've never considered, like the ability to interact with itself or even decay over time. That would mean we're not just looking at gaps, but at evidence of a far more complex dark universe, one where this enigmatic substance plays by rules we're only beginning to glimpse. The stakes here couldn't be higher. If dark matter behaves differently in NGC 1300, it undermines the very foundation of modern cosmology. Entire theories about galaxy formation, the universe's expansion, even the fate of everything we see, rely on dark matter being predictable and uniform. This galaxy's stubborn refusal to comply isn't just a curiosity, it's a cosmic revolt, challenging us to rethink the invisible machinery that shapes reality itself. And until we crack this puzzle, every dark patch in NGC 1300 stands as a silent question mark, daring us to look deeper. Some cosmic explosions arrive right on schedule, following lifetimes of predictable stellar decay. But in NGC 1300, there's a supernova that didn't just defy the timetable, it outright ignored it. Dubbed the time-delayed supernova, this stellar explosion detonated hundreds of thousands of years later than any model predicted, as if the star had somehow hit a cosmic snooze button before finally erupting. What makes this event so baffling isn't just the delay, it's the star that caused it. Supernovas typically come from two types of stars: massive ones that collapse under their own weight, or white dwarfs that steal too much material from a companion. But this progenitor star didn't fit either category neatly. Observations suggest it was a rare hybrid, a star caught in a twilight zone between normal stellar life and dramatic death, lingering far past its expected expiration date. So how could a star cheat time so spectacularly? One possibility involves a phenomenon called mass stripping. Imagine a massive star losing its outer layers prematurely, not through normal stellar winds, but through gravitational theft by a nearby black hole or dense star cluster. This could leave the star's core intact but unstable, delaying its inevitable collapse until the last critical thread snaps. Think of it as a building with its support beams slowly removed. It might stand far longer than engineers predict, but when it falls, the collapse is just as violent. Another theory points to an external trigger, something nudging the star over the edge. Perhaps a rogue planet or another star collided with it, injecting fresh energy into its core and jump-starting a chain reaction that should have happened eons earlier. Or maybe the star existed in a region of space where dark matter density fluctuated, subtly altering the physics inside its core like an unseen hand tightening a valve. But the most tantalizing explanation, that this supernova represents a completely new type of stellar death, one where stars can pause their own destruction through mechanisms we've yet to understand. Some researchers speculate magnetic fields could have played a role, with the progenitor star generating internal forces so strong they temporarily counteracted gravity's pull, creating a precarious equilibrium that held until something finally tipped the scales. Whatever the cause, the implications are staggering. If stars can postpone their explosions by cosmic lifetimes, it means our understanding of stellar life cycles and the elements they scatter into the universe might be woefully incomplete. This single delayed blast in NGC 1300 isn't just an anomaly. It's a challenge to every assumption about how stars live, die, and shape the galaxies around them. And until we solve its riddle, every ticking stellar clock in the universe suddenly seems a little less predictable. In the depths of NGC 1300, astronomers have captured something that shouldn't exist: images of the galaxy appearing stretched, duplicated, and warped as if viewed through a funhouse mirror. These aren't flaws in the telescope or glitches in the data. They're real distortions, signatures of gravitational lensing, where massive objects bend light like a magnifying glass. But here's the kicker: when scientists scour these regions for the culprit, they find nothing. No galaxy clusters, no black holes, not even a hint of dark matter dense enough to explain the effect. It's as if space itself is playing tricks on us, creating cosmic mirages with no visible source. The most striking example lies near the galaxy's western spiral arm, where a single star cluster appears in two places at once, separated by hundreds of light years. Normally, this kind of mirroring requires an intervening object with staggering mass, something like a supercluster of galaxies. Yet scans reveal empty space between the duplicates, a void where the lensing mass should be. Even stranger, the duplicated images don't match typical lensing patterns. Instead of clean arcs or symmetrical splits, they're twisted and uneven, like reflections in shattered glass. So what's bending light in NGC 1300 without leaving a trace? One possibility involves rogue structures made entirely of dark matter. invisible filaments so dense they warp space-time like a black hole, yet remain utterly undetectable to our instruments. Simulations suggest these dark strings could crisscross the universe, relics from the Big Bang, and NGC 1300 might sit where several intersect. If true, we're seeing light forced into detours around cosmic threads we can't see or touch. But there's a wilder idea on the table. What if the lensing isn't from an object at all? Some theorists propose these distortions could stem from space-time itself being fundamentally warped in this region. Imagine a patch of the universe where the fabric of reality is subtly crumpled, like a wrinkle in a tablecloth. Light passing through would bend unpredictably, creating illusions without any massive object to blame. Such warps might trace back to primordial quantum fluctuations frozen into the universe's structure, or even exotic energy fields left over from its earliest moments. Of course, the most haunting explanation is the simplest. We're missing something. Maybe the lensing mass is there, just hiding in plain sight. Could an entire population of primordial black holes, relics from the universe's birth, be lurking in these voids? Or perhaps an unknown form of matter, neither dark nor ordinary, exerts gravity without interacting with light in any way we've imagined. Whatever the truth, these mirages are more than optical illusions. They're clues hinting that NGC 1300 might be a crossroads of cosmic anomalies, where the rules of light and gravity don't apply as expected. And until we solve this puzzle, every distorted image serves as a reminder. Sometimes the universe's greatest mysteries aren't what we see, but what we can't. At the very heart of NGC 1300, where most barred spiral galaxies have a steady, rigid backbone of stars, something strange is happening. The central bar, that iconic structure crossing the galaxy's core, is behaving more like a spinning top losing momentum, wobbling erratically as if pushed by unseen hands. This isn't just a minor fluctuation. Over decades of observations, astronomers have watched the bar warp, twist, and even momentarily buckle in ways that defy every simulation of galactic dynamics. What makes this instability so puzzling is that bars are typically the most stable features in spiral galaxies. Think of them as cosmic scaffolding, dense with stars and locked into place by gravity's unbreakable grip. Yet in NGC 1300, this backbone seems almost loose. Some sections sway faster than others, creating ripples that travel along its length like vibrations in a plucked string. At times, entire segments appear to lag behind, as if the bar is tearing itself apart from within. So what could be shaking a structure that, by all rights, should be unshakable? One leading suspect is an invisible dance partner, a dwarf galaxy or dark matter clump passing through NGC 1300's core. Picture a pebble dropped into a pond, sending ripples outward. Only in this case, the pebble is a massive object we can't see, and the pond is a bar of millions of stars. Computer models show that even a small satellite galaxy, if it came too close, could transfer enough gravitational energy to set the bar wobbling for eons. But here's where it gets weirder. Scans reveal no obvious intruder, no shredded dwarf galaxies, no trails of stars hinting at a recent collision. That's led some researchers to propose an even more elusive culprit: clumps of dark matter, dense as mountains yet completely invisible, moving through the galaxy's heart like ghosts through walls. These clumps wouldn't just tug on the bar. Their gravitational tides could warp space-time itself, sending tremors through the stars in ways we're only beginning to model. Then there's the wildcard explanation. The bar might be unstable because it's young. Most galactic bars settle into their rhythms over billions of years, but what if NGC 1300's formed recently, still vibrating from its birth? Or worse, what if it's dying? Bars can dissolve over time, their stars scattered by gravitational chaos. If this one is in its death throes, its wobbles could be the last convulsions of a structure on the brink of collapse. The implications stretch far beyond this single galaxy. If bars can become unstable without clear cause, it challenges our entire understanding of how spiral galaxies evolve. Are these wobbles common across the universe, hidden in plain sight? Or is NGC 1300 a cosmic outlier, its restless heart beating to a rhythm we've yet to decipher? One thing's certain, every twist of that unstable bar is a message, a gravitational Morse code begging us to look closer. Because somewhere in those swaying stars lies a secret, one that could rewrite what we know about the skeletons of spiral galaxies. And until we solve it, the answer keeps slipping through our fingers, as elusive as the force that's shaking the galaxy at its core. Hidden among the glowing stars and swirling dust lanes of NGC 1300, something even more elusive flickers in and out of existence, mysterious X-ray sources that burn brilliantly one moment and vanish the next. These aren't your typical cosmic beacons. They appear without warning, flare with the intensity of a million suns, and then dissolve back into the darkness, leaving astronomers scrambling for answers. Scientists have dubbed them the phantom X-ray sources, and they're unlike anything else observed in the known universe. What makes these bursts so baffling is their sheer unpredictability. Most X-ray sources in space, like neutron stars or feeding black holes, emit steady, detectable signals. But these phantoms defy the rules, flaring up in regions where no known object should produce such intense energy, only to disappear before telescopes can pinpoint their exact origin. Some last for days, others wink out in mere hours, and when researchers train their instruments back on the same spot, more often than not, they find nothing but empty space. So what could possibly generate such erratic, high-energy outbursts? One leading theory points to a hidden population of intermediate mass black holes, cosmic middleweights lurking in the galaxy's spiral arms. Unlike their supermassive cousins at galactic centers, these black holes are nomads, drifting unseen until they snag a passing star or gas cloud. When they feed, the resulting X-ray flare could be spectacular, but brief, explaining why the signals vanish once the meal is over. Imagine a predator striking in the dark, its kill visible only as a flash before the night swallows it whole. But there's a twist. Some of these phantom sources don't align with any known stellar ruins or black hole activity. That's led to an even wilder possibility: exotic stellar remnants unlike any we've catalogued. Picture a super-dense object like a neutron star with an unthinkably strong magnetic field, or a quark star, a hypothetical state of matter so compressed it defies normal physics. Such an object could produce sporadic, ultra-powerful X-ray bursts as its crust fractures under unimaginable pressure, or as it interacts with rogue magnetic fields woven through the galaxy. Then there's the most provocative explanation: what if these sources aren't celestial objects at all? Some researchers speculate they could be evidence of dark matter annihilation, where hypothetical particles finally decay or collide after billions of years, releasing bursts of energy in the process. If true, these fleeting X-ray flashes wouldn't just be cosmic oddities. They'd be our first glimpse into the invisible particles shaping the universe. Of course, proving any of these theories is a challenge when the evidence keeps disappearing. But that's what makes NGC 1300's phantom X-ray sources so tantalizing. Each unexplained flare is a breadcrumb leading us toward discoveries that could rewrite the rules of high-energy astrophysics. And until we catch one in the act, or better yet, solve the mystery, every flicker serves as a reminder. The universe still holds shadows even our brightest telescopes can't fully illuminate. Far beyond the galaxy's bustling core, where the spiral arms stretch thin and the light of stars grows faint, NGC 1300 harbors one of its most unsettling secrets: a vast, churning vortex where the very fabric of motion seems to twist against the laws of physics. This cosmic whirlpool, lurking in the galaxy's outer reaches, isn't just a region of turbulent gas or swirling debris. It's a gravitational anomaly, a place where stars and interstellar material spiral inward in a pattern so precise, so unnaturally organized. It's as if some invisible hand has stirred the galaxy like a cup of coffee. At first glance, the whirlpool resembles the aftermath of a galactic merger, the kind of chaotic dance that occurs when two galaxies collide and their stars are scrambled into new orbits. But here's the catch: NGC 1300 shows no other signs of a violent past. No tidal tails of scattered stars, no warped disk, none of the usual scars left behind by such a cataclysmic event. Instead, this vortex exists in eerie isolation, a perfect spiral within a spiral, rotating with a rhythm that defies explanation. So what could be driving this mysterious motion? One possibility is a long-dead merger, a ghostly echo of a smaller galaxy swallowed billions of years ago. Simulations suggest that under the right conditions, the gravitational ripples from such an event could persist for eons, subtly herding stars and gas into unnatural patterns long after the intruder galaxy has been digested. Think of it like tossing a stone into a pond. The initial splash vanishes quickly, but the ripples can linger, reshaping the surface in ways that hint at the disturbance long after it's gone. But there's a flaw in that theory. The whirlpool's motion is too clean, too symmetrical for a typical merger remnant. That's led some researchers to propose an even stranger explanation, an unseen force still active today. Could a rogue supermassive black hole ejected from the galaxy's core during some ancient upheaval now prowl the outer edges, its gravity carving this perfect spiral as it drifts through the void? Or perhaps a knot of dark matter, denser than anywhere else in the galaxy, has pooled in this region, its invisible mass warping the paths of stars like a cosmic whirlpool draining into some hidden abyss. Then there's the wildest idea of all: what if this vortex isn't the result of something that happened in the past, but a sign of something happening now? Some theorists speculate that NGC 1300 might be brushing against an entirely unseen structure, a filament of dark matter, or even a parallel universe's gravitational shadow, tugging at the galaxy's outer edges in ways we can't yet comprehend. It sounds like science fiction, but in a universe where dark energy accelerates expansion and black holes warp time, who's to say where the limits of reality truly lie? What makes this whirlpool so fascinating isn't just its existence, but what it reveals about how little we understand galactic dynamics. If a structure this pronounced can form without obvious cause, what other invisible forces might be shaping galaxies in ways we've yet to notice? Every star caught in that spiral is a clue, a silent witness to whatever mystery lies at the heart of this cosmic whirlpool. And until we solve it, the vortex keeps turning, a hypnotic, unanswered question written in the motions of the stars themselves. Deep in the swirling arms of NGC 1300, astronomers have stumbled upon a cosmic contradiction, stellar nurseries that shouldn't exist. These are regions where newborn stars gleam in tight clusters, their youthful brilliance impossible to miss, yet when scientists search for the gas clouds required to birth them, they find nothing but empty space. It's as if these stars appeared out of thin air, defying every known rule of how star formation works. How can you have a nursery without the crib? The puzzle begins with the basics. Stars form when dense pockets of gas collapse under gravity, heating up until nuclear fusion ignites. This process leaves clear fingerprints. Giant molecular clouds, thick with hydrogen and dust, should surround every young star like a cosmic womb. But in these invisible nurseries, the gas is conspicuously absent. Scans that would normally reveal swirling nurseries instead show eerie voids, as if someone whisked away the stellar raw material after the fact. So where did these stars come from? One explanation points to stealthy reservoirs of dark gas clouds so cold and diffuse they evade detection by conventional telescopes. Imagine a fog so thin it's invisible unless you're standing right in it. These ghostly clouds might contain enough mass to spawn stars, yet remain transparent to our instruments, hiding in plain sight until gravity does its work. If true, it would mean we've only been seeing half the story of star birth, missing an entire shadow population of stellar fuel. But there's a twist. Some of these star clusters are too young for their birth clouds to have simply dispersed. Normally, it takes millions of years for radiation and stellar winds to blow away a nursery's gas. Yet here, stars still in their infancy already sit in pristine emptiness, as if their cradles evaporated overnight. That's led to a more radical idea. Could these stars have formed through a completely different mechanism? Some theorists suggest extreme turbulence or magnetic fields might have compressed gas faster than usual, creating stars in a cosmic blink before the cloud could be detected. Others propose cascading shock waves from nearby supernova, triggering rapid star formation like a chain reaction. Then there's the wildcard possibility. These stars didn't form locally at all. Could they have migrated here from elsewhere in the galaxy, tugged by passing black holes or dark matter currents? It's a long shot, but in a place as unpredictable as NGC 1300, even the unlikeliest scenarios demand consideration. The implications ripple far beyond this single galaxy. If stars can form without leaving the usual traces, it challenges our very definition of stellar nurseries and forces us to ask what else we might be missing in the depths of space. Every invisible nursery in NGC 1300 is a cosmic lesson, reminding us that the universe still holds secrets in the places we least expect. And until we solve this riddle, the stars born from nothing will keep shining, silently daring us to uncover their origins. In the very center of NGC 1300, astronomers have detected something that shouldn't be there, a rhythm. Not the steady thrum of a spinning black hole or the chaotic bursts of a feeding quasar, but a precise metronomic pulse echoing through the galaxy's core like a cosmic heartbeat. These aren't random fluctuations, they're rhythmic oscillations repeating every 63 days with uncanny regularity, as if the galaxy itself is breathing. The first signs of this phenomenon came from X-ray telescopes, which picked up surges of energy flaring and fading like clockwork. At first, researchers assumed it was a glitch, some quirk of instrumentation or a passing cosmic ray. But as months turned to years, the pattern held. Every 63 days, like a celestial metronome, the galaxy's core brightened and dimmed, its pulse so steady it could set your watch to it. So what could possibly cause such a precise cosmic rhythm? One leading theory points to an oscillating black hole. Most supermassive black holes feed continuously, their accretion disks glowing with a messy, unpredictable brilliance. But if NGC 1300's black hole were wobbling tilted on its axis like a spinning top, it might swallow material in bursts, flaring each time a fresh wave of gas sloshes into its maw. Picture a faucet dripping into a drain. If the flow is just right, each drop creates a ripple at the same interval. But there's another, even stranger possibility: resonance. Galaxies aren't static structures. Their stars, gas, and dark matter vibrate like the strings of an instrument, creating subtle waves that ripple through the disk. Normally, these vibrations cancel each other out, but if one frequency dominates, it could create a standing wave, a sort of galactic hum that amplifies every 63 days. Imagine blowing across the mouth of a bottle, the pitch determined by the air inside. Now scale that up to a galaxy where the note is a pulse of X-rays and the bottle is a swirling maelstrom of stars and dark matter. Then there's the wildcard explanation, something entirely new. Could this heartbeat be evidence of a binary black hole system where two supermassive monsters orbit each other, their gravitational dance sloshing gas into the primary black hole on a strict schedule? Or perhaps the pulse stems from a rare alignment where a dense star cluster or dark matter knot swings perilously close to the black hole on a fixed timetable, stirring the accretion disk like a spoon in coffee. The implications are profound. If black holes can pulse with this kind of regularity, it challenges our assumptions about how they feed and how they shape their galaxies. Are these rhythms common across the universe, hidden in plain sight? Or is NGC 1300's heartbeat a cosmic freak, a one-in-a-billion anomaly that we're only lucky enough to witness? One thing's certain, every pulse from this galaxy's core is a clue, a rhythmic whisper hinting at forces we've yet to understand. And until we solve this mystery, the heartbeat keeps ticking, a cosmic clock counting down to answers we're only beginning to chase. One of the most puzzling contradictions in NGC 1300 lies in its chemistry, or rather the lack of it. Scattered across its spiral arms are vast pockets of gas with staggeringly low metal content, regions where the cosmic ingredients for planets, life, and even future stars seem to have gone missing. Astronomers call this the missing metallicity problem, and it's throwing decades of galactic evolution models into question. Because if there's one thing we thought we understood, it's that galaxies should grow richer in metals over time, as generations of stars forge heavier elements and scatter them into the void. Yet here, entire swaths of space cling to primordial purity, as if time itself forgot to move forward. The mystery starts with the basics. Metals, everything heavier than hydrogen and helium in cosmic terms, are supposed to accumulate like dust in an old attic. Supernovae explode, neutron stars collide, and dying stars shed their outer layers, each event seeding the galaxy with elements like carbon, oxygen, and iron. Given NGC 1300's age, its gas should be peppered with these metals by now. But in these anomalous zones, spectroscopic readings reveal gas nearly as pristine as it was just after the Big Bang, with metal abundances hundreds of times lower than expected. It's like finding untouched wilderness in the middle of a sprawling metropolis. So where did the metals go, or more intriguingly, why were they never there to begin with? One leading theory involves cosmic recycling gone wrong. Normally, galaxies continuously churn their gas, mixing enriched material back into the interstellar medium. But simulations suggest that under certain conditions like unusually strong magnetic fields or turbulent gas flows, pockets of gas might escape this mixing, remaining isolated for billions of years. Picture a whirlpool where some water gets trapped in quiet eddies, never rejoining the current. These pristine pockets could be the galactic equivalent, preserved in a chemical time capsule since the universe's infancy. But there's a twist. Some of these metal-poor regions sit disturbingly close to areas brimming with stellar activity, where supernova should have polluted the neighborhood long ago. That's led to a wilder idea: fresh inflows of virgin gas from intergalactic space. Imagine cosmic rivers, streams of never-used hydrogen and helium trickling in from the barren voids between galaxies, diluting the metal content like rainwater flushing through a pipe. If true, it would mean NGC 1300 isn't just evolving in isolation. It's still gulping down leftovers from the universe's primordial soup. Then there's the most radical explanation of all. What if these regions aren't deficient in metals but hiding them? Some researchers speculate that under extreme conditions, like near a black hole's gravitational well, metals could clump into dust grains so large they evade detection, or even get locked away in strange quantum states. It's a cosmic shell game where the heavier elements haven't vanished, just slipped into forms our telescopes can't yet see. The implications ripple far beyond this single galaxy. If pristine gas can persist or reappear in mature galaxies, it upends our timeline for when and how cosmic chemistry unfolds. Could there be corners of the Milky Way just as untouched? And what does that mean for the birthplaces of future stars, planets, and perhaps even life? NGC 1300's missing metals aren't just a celestial oddity, they're a silent challenge, daring us to rethink how the universe seasons its grandest structures. Until we solve the riddle, these chemical deserts remain cosmic blank spots, whispering of processes we've yet to imagine. Among the many mysteries NGC 1300 holds, few are as visually mesmerizing as the celestial mirage, ghostly, imperfect copies of the galaxy itself flickering in deep space images like reflections in a broken mirror. These aren't the crisp duplicates produced by typical gravitational lensing, where massive foreground objects bend light into perfect arcs or rings. Instead, they're distorted, fragmented echoes of NGC 1300, scattered across the cosmic backdrop as if space itself has developed a glitch. The first hints of this mirage emerged when astronomers noticed faint smudges in long-exposure images, blurry patches with the same spiral structure as the galaxy, but shifted slightly in position and warped in impossible ways. At first, they were dismissed as artifacts or camera noise, but as observations piled up, the truth became undeniable. These weren't imaging errors. They were real, if ghostly, reproductions of NGC 1300, floating where no galaxy should be. So what could possibly create such a bizarre cosmic photocopy? The leading explanation points to an invisible cosmic lens, something massive enough to warp light, yet too diffuse to detect directly. Most gravitational lenses are galaxy clusters, their combined gravity acting like a magnifying glass. But here, there's no such structure in sight. That's led to a radical idea. Perhaps the lens isn't a single object, but a web of dark matter filaments crisscrossing the line of sight. Picture a spiderweb strung across a window, subtly distorting the view beyond. If dark matter forms similar threads in intergalactic space, they could bend light just enough to create these warped reflections without revealing their own presence. But there's a catch. The mirage copies don't behave like normal lensed images. They're too asymmetrical, their distortions too chaotic. That inconsistency has birthed an even wilder theory. What if space-time itself is wrinkled here, just as a crumpled sheet of paper reflects light at odd angles? Primordial ripples in the universe's fabric left over from the Big Bang's violent birth might scatter NGC 1300's image across the sky. It's a cosmic hall of mirrors where the glass is bent and no reflection quite matches the original. Then there's the spine-tingling alternative. These mirages might not be reflections at all. Could they be evidence of a parallel universe brushing against our own? Its gravitational shadow briefly imprinting NGC 1300's likeness onto our sky. The math isn't as far-fetched as it sounds. Certain multiverse theories predict such overlaps, where neighboring universes in the cosmic foam interact weakly through gravity alone. If true, these faint copies could be the first hints of a reality beyond our own, glimpsed through the thinnest of veils. Of course, the simplest answer is often the right one. We're just missing a piece of the puzzle. Maybe an unseen galaxy cluster lurks behind NGC 1300, its gravity twisted by intervening dust. Or perhaps the mirage stems from something far more mundane, like light bouncing off an undetected molecular cloud in our own galaxy. But in a place as unpredictable as NGC 1300, even the mundane explanations feel extraordinary. Whatever the cause, these phantom copies challenge our understanding of light, gravity, and the very structure of space. Every faint smudge is a question written in starlight, one that might lead us to discoveries far stranger than we dare imagine. And until we unravel this cosmic hall of mirrors, the mirages will keep shimmering, taunting us with reflections of a reality just out of reach. At the heart of most galaxies, supermassive black holes announce their presence with terrifying brilliance, quasars brighter than 1 trillion suns, jets of plasma stretching across light years, and swirling accretion disks glowing with X-rays. But NGC 1300's central black hole breaks the mold by doing something far more unsettling: nothing. This cosmic leviathan, weighing millions of times our sun's mass, sits in near-perfect silence, emitting less radiation than some backyard telescopes could detect. It's not just quiet, it's suspiciously, unnaturally hushed, like a predator holding its breath in the dark. This silence defies everything we know about how supermassive black holes behave. Normally, even dormant ones occasionally snack on passing gas clouds or stars, producing telltale flares. But NGC 1300's core remains eerily dark, with no signs of feeding activity for decades of observations. Imagine finding a sleeping dragon that never stirs, never breathes fire, no matter how many nights poke it. That's how baffling this black hole's passivity appears to astronomers. So what could render a monster this powerful so silent? One possibility is an extreme case of cosmic dieting. Black holes shine when they consume matter, but if NGC 1300's core has somehow been starved, perhaps by unusually efficient magnetic fields deflecting gas away, it might sit dormant for eons. Picture a waterfall blocked by an invisible dam. No flow means no roar, no spray, just stillness where there should be chaos. But the more intriguing theory involves camouflage. Some researchers suggest this black hole isn't dormant at all. It's feasting behind an impenetrable shroud. Thick cocoons of dust or dense molecular clouds could be blocking all emitted radiation, turning what should be a blazing beacon into a shadow. There's precedent for this. Our own Milky Way's central black hole was once thought unusually quiet until infrared observations pierced its dusty veil, revealing hidden activity. Then there's the wild card. What if this silence hints at a new evolutionary stage? Most galactic black holes cycle between active and dormant periods, but NGC 1300's might represent something rarer. A black hole in permanent retirement, having ejected or consumed all nearby material long ago. Or perhaps it's switched to a mode we've never witnessed, funneling energy into gravitational waves or dark matter interactions instead of light. The implications ripple far beyond one galaxy. If black holes can become this silent without dying, it means we might be missing thousands, maybe millions, of them in our cosmic surveys, hidden in plain sight. Every ultra-quiet giant like this challenges our senses of the universe's most powerful objects, and reminds us that sometimes the most terrifying things in space are the ones we can't see at all. Stretching across the glowing tapestry of NGC 1300 are patches of pure darkness, voids so dense they swallow starlight whole. These aren't ordinary shadows cast by dust or gas. They're cosmic black holes in the most literal sense, regions where light vanishes without a trace, leaving behind silhouettes that defy explanation. Astronomers call them the galactic shadows, and they're among the most perplexing features in this already mysterious galaxy. What makes these shadows so unsettling is their sheer opacity. Normal interstellar dust clouds dim starlight, scattering it into beautiful red hues, like sunlight filtering through smoke, but these patches don't scatter. They absorb. Light hitting them doesn't re-emerge shifted in color, it simply disappears. It's as if someone cut holes in the fabric of the galaxy, leaving behind gaps where physics itself seems to pause. The first instinct is to blame hyper-dense dust clouds, regions where grains have clumped together so tightly they form an almost solid barrier. Under extreme conditions, dust particles could theoretically grow large enough to block all wavelengths of light, creating perfect blackout zones. But here's the catch: even the densest known dust clouds can't explain the shadow's scale. Some stretch hundreds of light years across, far larger than any dust structure should remain stable. That's where darker theories emerge. Could these shadows be the fingerprints of something invisible? Dark matter, which makes up most of the universe's mass but interacts weakly with light, might clump into structures so dense they warp space itself. Picture a cosmic sponge, its filaments so thick with dark matter that passing light gets trapped in the folds. Alternatively, some researchers propose primordial black holes, ancient relics from the Big Bang lurking in these voids, their collective gravity bending light away before it can reach our telescopes. Yet the most tantalizing idea is also the most speculative. What if these shadows aren't made of matter at all, but of absence? Theoretical models suggest certain quantum fluctuations in the early universe could have created topological defects, weird wrinkles in space-time where the rules of physics change slightly. If NGC 1300's shadows mark such defects, they'd be less like objects and more like glitches in reality, regions where light doesn't so much get absorbed as it gets lost in the cosmic code. Of course, the likeliest explanation is still mundane, just not mundane by human standards. Maybe these shadows are vast stellar graveyards, the remnants of a catastrophic event that filled space with cold, lightless debris. Or perhaps they're the aftermath of a galactic collision, where two immense gas clouds slammed together so violently they formed a temporary light-blocking shell. Whatever their origin, these shadows do more than just hide starlight. They hide answers. Every patch of darkness is a question mark, challenging our assumptions about how matter behaves in the extremes of deep space. And until we pull back the curtain on these cosmic blackouts, they'll remain fittingly some of NGC 1300's deepest enigmas. Tucked away in the spiral arms of NGC 1300, a group of celestial elders whispers secrets of a time before the galaxy itself took shape. These are the stellar time capsule stars so ancient, their ages predate the very structure they now call home. Imagine finding a fossilized tree buried beneath a modern city, its rings telling a story older than the streets above. That's the paradox lurking in these stars. They shouldn't exist here, at least not by our current understanding of galactic evolution. The first clues came from spectral analysis, where astronomers measured the chemical fingerprints of these stars and found something startling. They contained almost no heavy elements. In cosmic terms, that's like finding a library filled with books written in a language from before the alphabet was invented. Stars born early in the universe's history formed from pristine hydrogen and helium, their compositions untouched by the recycled material of later generations. Normally, such ancient relics are confined to the outskirts of galaxies or drifting in lonely isolation between them. Yet here they are, embedded deep within a relatively young spiral galaxy, as if someone planted them there deliberately. How did these cosmic elders end up in a place that shouldn't host them? One possibility is galactic archaeology gone wild. NGC 1300 might have cannibalized a much older dwarf galaxy in its distant past, absorbing its stars like a cosmic sponge soaking up water. Picture a bustling metropolis swallowing a forgotten village whole, its cobblestone streets now paved over by modern roads. The stars, once belonging to that swallowed system, would retain their primordial signatures even as they became part of a new galactic order. But there's a problem. Some of these time capsule stars are clustered together in ways that don't match typical merger patterns. That's led to a wilder idea. They might be survivors from an earlier phase of the universe, stars that formed in the chaotic conditions just after the Big Bang and somehow avoided being destroyed or enriched for billions of years. Think of them as celestial ice cubes floating in a glass of whiskey, resisting dilution against all odds. If true, their presence in NGC 1300 would mean the galaxy somehow preserved a pocket of the early cosmos, a bubble of ancient physics frozen in time. Then there's the most tantalizing explanation. These stars might not be immigrants at all. Could they have formed in place through a process we've never witnessed? Some theorists speculate that under extreme conditions like an unexpected collision with a dark matter filament or a primordial gas cloud stars might still emerge with these bizarrely pure compositions even in later cosmic epochs. It's a long shot, but in a galaxy as unpredictable as NGC 1300, even the most improbable scenarios can't be ruled out. What makes these stellar time capsules so invaluable isn't just their age, it's what they reveal about the universe's infancy. Each one is a living relic carrying chemical clues about the conditions moments after the Big Bang. Studying them is like cracking open a cosmic safe, revealing secrets about how the first stars ignited, how galaxies assembled, and how the universe transitioned from simplicity to complexity. Yet their very existence here raises more questions than answers. If such ancient stars can persist or even form in a modern galaxy, what else have we gotten wrong about stellar evolution? Are there other pockets of the primordial universe hidden in plain sight, waiting to rewrite our cosmic timeline? Until we solve this riddle, these time-worn sentinels will keep burning silently, their light a code we're only beginning to decipher. But perhaps the most ghostly spectacle in NGC 1300 isn't what's hidden, it's what lingers. Drifting out from the galaxy's core like a fading breath, an ethereal jet of high-energy particles stretches into the void, so faint it's barely detectable, yet too structured to dismiss as cosmic noise. Astronomers call it the phantom jet, and it's unlike anything else observed in the known universe. Most galactic jets roar into space with the fury of a supermassive black hole's appetite, blazing across millions of light years. This one, it whispers, a spectral remnant of some forgotten eruption, or perhaps the dying echo of a force we've yet to understand. The first thing that strikes researchers is the jet's asymmetry. Normally, active galaxies shoot twin jets in opposite directions, balanced by the spinning black hole's poles. But here, only one side remains a lopsided relic, as if its counterpart vanished without a trace. Spectroscopic analysis reveals it's not just dim. Its particles are oddly cold compared to typical jets, lacking the blistering heat of freshly accelerated matter. It's as if someone turned off the engine mid-flight, leaving this solitary stream to coast on momentum alone. So what could have produced such a ghostly structure? One compelling theory points to a cataclysmic event in the galaxies past, a black hole eruption that flared briefly, then collapsed before fully igniting. Picture a volcano that begins to erupt, only to choke on its own ash, leaving behind a single plume of smoke. If NGC 1300's central black hole experienced a short-lived feeding frenzy, perhaps after gulping down a wayward star, it might have launched this jet before retreating into dormancy. The particles, now drifting without power, would have cooled over millennia, fading into the eerie afterglow we see today. But there's a twist: the jet's path isn't straight. It curves subtly, like a ribbon caught in an invisible breeze. That unruliness hints at external forces at play, maybe the gravitational tug of a hidden companion black hole, or the pressure of an unseen dark matter filament warping its trajectory. Some researchers even speculate the jet might be older than it appears, a fossil from an era when the galaxy's core was violently active, its bends accumulated over eons like wrinkles in an ancient face. Then there's the spine-tingling alternative: the phantom jet isn't fading at all. What if it's still being fed, just in a way we can't detect? Current telescopes might be missing ultra-faint X-rays or neutrinos that could reveal ongoing activity. Or perhaps the black hole isn't dormant, it's switched to a stealth mode, channeling energy into forms of radiation or particles that slip past our instruments unnoticed. Imagine a flashlight shining in a spectrum only certain eyes can see. The jet might be just as real, just as powerful, but invisible to our current tools. The implications ripple far beyond this single galaxy. If jets can persist or form in such ghostly states, it means we might be missing countless others camouflaged across the cosmos. Every silent, fading stream could be a clue, a breadcrumb leading us toward understanding black holes' final acts. And until we solve the phantom jet's riddle, it remains a cosmic afterimage, a fleeting brushstroke left on the canvas of deep space by forces we're only beginning to trace. Stretching across the face of NGC 1300 like the wake of some unseen cosmic ship, vast undulating waves distort the galaxy's disk in ways that defy simple explanation. These aren't the gentle density waves responsible for spiral arms. These are gargantuan ripples, light years tall, warping the galactic plane like a sheet of tin foil crumpled under an invisible hand. Their presence suggests forces at work far beyond the ordinary push and pull of gravity, hints of a turbulent past, or perhaps an unseen present that's left the galaxy trembling in its wake. The ripples reveal themselves through subtle but unmistakable distortions. Entire star clusters appear displaced, their positions oscillating above and below the galactic plane in synchronized patterns. Gas clouds that should lie flat instead undulate like frozen ocean waves, their peaks and troughs aligned across staggering distances. Most perplexing of all, these structures aren't random. They form coherent arcs, concentric rings of disturbance radiating outward from the galaxy's core, as if NGC 1300 was struck by something immense and left vibrating ever since. What could send such enormous shudders through an entire galaxy? The leading suspect is a brutal collision in the distant past. When galaxies merge, the gravitational shockwaves can reverberate for billions of years, like a gong struck once but never allowed to fully quiet. Computer simulations show that a glancing blow from a dwarf galaxy, or even a direct hit from a rogue gas cloud massive enough to rival small galaxies, could set off these oscillations. Imagine dropping a stone into a pond, then freezing the ripples mid-motion and scaling them up to galactic proportions. That's the kind of violence these waves might preserve. Yet there's a problem with the collision theory. The ripples are too orderly, their spacing too precise for a random impact. That's led some researchers to propose an even stranger catalyst, dark matter currents. If NGC 1300 is moving through a dense river of dark matter, one of the universe's hypothetical cosmic filaments, its gravitational drag could be plucking at the galaxy's disk like fingers strumming a harp. Unlike ordinary matter, dark matter wouldn't leave behind glowing debris or shredded stars as evidence. Its influence would be invisible, detectable only through the ghostly vibrations it imparts. Then there's the most unsettling possibility of all, that these ripples aren't relics but ongoing phenomena. Could something buried in the galaxy's core be pulsing, sending regular gravitational tremors through the disk? A supermassive black hole with a lopsided accretion disk might wobble as it spins, its off-kilter mass acting like a cosmic unbalanced washer in a washing machine. Or perhaps a population of intermediate mass black holes, swinging around each other in tight orbits, generate rhythmic gravitational waves that literally shake the galaxy from within. The implications ripple outward far beyond NGC 1300. If such large-scale distortions can persist, or even form without obvious cause, it means we might be missing similar structures in other galaxies, their subtle warping overlooked in our surveys. Every undulation in this galaxy's disk is a clue, a frozen moment in a story we're only beginning to read. And until we decode whether these waves stem from ancient impacts, dark matter's whisper, or something even stranger, they'll keep rolling through NGC 1300 silent, relentless, and utterly mysterious. NGC 1300 moves through space with an odd hitch in its step, a subtle wobble that suggests it's not traveling alone. Despite its vast spiral arms stretching proudly across the cosmos, something unseen tugs at its motion, as if invisible hands guide its path. Astronomers call these phantom influences the invisible companions, and they might just rewrite everything we thought we knew about how galaxies navigate the universe. The first clues came from careful measurements of the galaxy's trajectory. Like a ship leaving a faint wake in water, galaxies often betray the presence of nearby objects through gravitational disturbances. But in NGC 1300's case, the expected culprits, dwarf galaxies or star clusters, are nowhere to be found. Instead, the galaxy's peculiar drift points to massive, unseen neighbors lurking just beyond the edges of our telescope's vision. It's as if the galaxy is caught in a cosmic dance with partners we can't see, their presence felt only through the weight of their steps. So who or what are these hidden companions? One compelling theory points to dark matter halos, vast and invisible cocoons of mysterious particles that swarm around galaxies like ghostly attendants. These halos could be far larger and more complex than we've modeled, extending tendrils deep into intergalactic space. If NGC 1300's dark matter halo is lopsided or stretched unusually thin, it might explain the galaxy's irregular motion, like a dancer pulled off balance by an unseen hand gripping their cloak. But there's another, even more tantalizing possibility, a family of dark galaxies. These would be entire dwarf galaxies made almost entirely of dark matter, their few stars so sparse they blend into the cosmic background. Such shadowy structures have been hypothesized before, but NGC 1300's peculiar movements might finally provide evidence they exist. Picture a ghostly entourage trailing the main galaxy, their gravitational influence the only sign they're there at all, like whispers in the dark felt more than heard. The implications ripple far beyond this single galaxy. If dark galaxies or lopsided halos are common, it means our current maps of the universe are missing entire chapters of the cosmic story. Galactic motions we've long attributed to known forces might instead stem from these unseen actors, shifting our understanding of how gravity shapes the cosmos. And until we detect them directly, or unravel their influence fully, NGC 1300's invisible companions will keep tugging at our theories, silently reshaping the universe in ways we're only beginning to sense. Deep within the spiraling arms of NGC 1300, electromagnetic whispers bounce back in ways that make no sense, a cosmic echo chamber where signals don't just fade, they return with eerie precision. Astronomers have detected regions where radio waves, X-rays, even visible light pulse through space only to rebound moments later, as if the galaxy itself were folding time to replay its own transmissions. These aren't random reverberations, they're structured, rhythmic, and localized to specific pockets of the galaxy, where the laws of signal propagation seem rewritten by an unseen hand. The first recorded echo came from a routine scan of a seemingly unremarkable nebula. A burst of radio emissions likely from a collapsing star flared briefly, then repeated itself not once but twice, each iteration fainter yet identical in frequency structure, like a recording played back on delay. Subsequent observations revealed more of these echo zones, areas where electromagnetic energy lingers unnaturally, trapped in loops that defy the light-speed certainty of deep space. It's as if patches of NGC 1300 have been tuned like tuning forks, resonating at frequencies that catch and amplify certain signals while letting others pass unimpeded. So what could twist empty space into a cosmic soundboard? One explanation points to magnetized plasma labyrinths, vast, twisted webs of ionized gas threaded with magnetic fields so intense they bend radiation into closed loops. Picture shouting into a canyon where the walls are made of mirrors. Some sound waves escape while others ricochet endlessly in shrinking arcs. In NGC 1300, turbulent star-forming regions or supernova remnants might have forged these electromagnetic hallways, their chaotic energy sculpting temporary echo chambers where signals bounce like pinballs. But there's a catch. Some echoes recur long after their source event has faded, with delays that can't be explained by simple plasma physics. That's led to wilder theories like space-time curvature traps. If dark matter or rogue black holes warp local geometry into closed time-like curves, Einsteinian loops where light could theoretically orbit signals might circle these distortions before escaping, arriving late and ghostly. Imagine a flashlight beam bent around a cosmic knot, emerging seconds or even years after it was emitted, its path twisted by invisible fingers of gravity. Then there's the spine-tingling fringe hypothesis, structured repetition. A handful of echoes don't just mirror their source signals, they subtly evolve as if being reprocessed by something that isn't just reflecting but interpreting. It's the difference between an echo and an answer. While most scientists attribute this to harmonic stacking where overlapping frequencies create phantom patterns, a daring few wonder if we're glimpsing a natural or unnatural feedback system, a relic of some ancient technology or a phenomenon so advanced it blurs the line between physics and something beyond. Whatever the truth, these echo zones aren't just curiosities, they're stress tests for our understanding of information itself. In a universe where causality is sacrosanct, where signals should travel obediently at light speed, NGC 1300's reverberations whisper of exceptions, places where the rules fray at the edges. Every repeated pulse is a riddle wrapped in an enigma, challenging us to listen closer, not just to the echoes, but to what they might be trying to say. In the tapestry of NGC 1300, where stars cluster in glowing swirls and nebulas paint the darkness with color, there exists a blank spot, a region so devoid of light it looks like a hole punched through the galaxy itself. This is the starless void, a stretch of space spanning hundreds of light years where telescopes find nothing, no stars, no gas, not even the faintest wisps of dust. It's not just dark, it's unnervingly empty, as if someone reached into the galaxy and scooped out everything inside. What makes this void so unsettling isn't its size, though it's vast enough to swallow our solar system thousands of times over. It's the abruptness of its edges. Unlike typical interstellar voids which taper off gradually, this one ends as sharply as if drawn with a knife. One moment, a bustling stellar neighborhood, the next pure nothingness. The transition is so sudden, so unnatural, that astronomers have spent years ruling out instrument errors before accepting the impossible truth. This void is real. And it shouldn't be. So how does a galaxy lose an entire pocket of itself? One theory points to an ancient cataclysm, a supermassive black hole that once passed through this region, devouring everything in its path before drifting away. Picture a shark slicing through a school of fish, leaving only stillness behind. Such rogue black holes, if they exist, could explain the void's cleanliness. Their gravity would have stripped away stars and gas, while their wake would have scattered any remaining debris beyond detection. But there's a flaw in that explanation. Black holes, even supermassive ones, leave traces, ripples in surrounding star fields, heat signatures in leftover gas. Here, there's nothing, no X-ray echoes, no distorted orbits in nearby stars. That absence has led to a wilder idea. The void might be a cosmic vacuum, a region where dark energy, the mysterious force accelerating the universe's expansion, has become locally amplified, pushing matter away like an invisible repelling magnet. If true, it would mean pockets of space can actively repel stars and gas, creating these unnatural deserts. Then there's the most haunting possibility: the void isn't empty at all. What if it's filled with something our instruments can't see? Dark matter, in its most exotic forms, might cluster here in structures so dense they block normal matter from entering, like an invisible force field. Or perhaps this is the footprint of a long-vanished civilization, one that somehow erased this sector of space either by accident or design. Far-fetched. Absolutely, but in a galaxy already brimming with anomalies, even the wildest theories deserve a glance. Whatever its origin, the starless void is more than a curiosity, it's a challenge. Its existence forces us to question whether similar voids hide in other galaxies, overlooked because they defy expectation. And until we solve its riddle, this perfect blank spot will keep staring back at us, silent and indifferent, a cosmic question mark written in the negative space of the universe. Magnetic fields are supposed to be the universe's gentle guides, invisible threads that help shape galaxies into orderly spirals and coax gas clouds into newborn stars. But in NGC 1300, these cosmic forces have taken a chaotic turn. Here, the galaxy's magnetic fields don't just bend, they twist, tangle, and knot themselves into configurations so bizarre they've left astrophysicists scratching their heads. These aren't the smooth, sweeping lines we see in most spiral galaxies. They're frenzied, crumpled, almost violent in their disarray, as if someone took a cosmic comb to the galaxy's magnetic fabric and deliberately scrambled it. What makes these twisted fields so puzzling is their sheer unpredictability. Normally, a galaxy's magnetic field aligns roughly with its spiral arms, following the flow of gas and stars like orderly lanes of traffic. But in NGC 1300, polarimetry readings reveal something far stranger: fields that suddenly reverse direction, loop into figure eights, or even form localized whirlpools strong enough to warp nearby star-forming regions. It's like finding a stretch of highway where the lanes suddenly spiral into labyrinths, throwing every rule of navigation out the window. The effects of this magnetic chaos ripple across the galaxy. Star formation, which relies on calm, collapsing gas clouds, gets disrupted wherever these turbulent fields dominate. Some nebulas appear shredded, their gas pulled into filamentary wisps by competing magnetic forces. Elsewhere, young star clusters show abnormal distributions, their usual symmetrical groupings skewed into strange arcs and clumps. Even more baffling, certain regions exhibit magnetic deserts, pockets where the field strength drops to near zero, leaving gas clouds adrift without their usual electromagnetic scaffolding. So what could warp a galaxy's magnetic architecture so thoroughly? One leading theory points to a history of galactic collisions. If NGC 1300 merged with another galaxy long ago, the gravitational turmoil could have stirred its magnetic fields like spoons in a turbulent drink, leaving behind a legacy of tangled line. Simulations show such mergers can twist fields into knots that take billions of years to smooth out if they ever do. Yet there's a problem. NGC 1300 lacks other telltale signs of a recent merger, like tidal tails or disrupted stellar orbits. That missing evidence has given rise to a wilder idea: dark matter interference. Some researchers speculate that dense clumps of dark matter, drifting through the galaxy's disk, might be warping the magnetic fields indirectly, not through electromagnetism, which dark matter ignores, but through sheer gravitational distortion. Picture a heavy object rolling under a rug, creating bumps that drag the fabric with it. If dark matter's invisible lumps are doing the same to spacetime itself, the resulting ripples could twist the galaxy's magnetic scaffolding into these bizarre configurations. Then there's the most electrifying possibility that we're witnessing magnetic feedback from the galaxy's core. Supermassive black holes don't just swallow matter, they also spew out colossal jets of charged particles which can carry magnetic fields like invisible wires. If NGC 1300's central black hole had an active phase in the recent cosmic past, its jets might have pumped twisted magnetic energy into the galaxy's disk, leaving behind this knotted legacy. It's the astrophysical equivalent of a power surge scrambling a computer's circuits, only here the circuits are light years wide and the damage lasts for eons. The implications stretch far beyond this single galaxy. If magnetic fields can tangle this severely without obvious cause, it forces us to reconsider how they influence galactic evolution. Could similar scrambles explain star formation quirks in other galaxies? Are we underestimating magnetism's role in shaping the universe? Every twisted line in NGC 1300's magnetic map is a clue, and until we unravel its secrets, this cosmic knot will keep tugging at the boundaries of our understanding. Among the countless stars drifting through NGC 1300, a peculiar pattern emerges: not chaos but choreography. Astronomers have pinpointed groups of stars moving in uncanny lockstep, their orbits aligning with such precision it's as if they're dancing to the same cosmic rhythm. This isn't just random chance or the gentle tug of a nearby spiral arm. These stars, separated by hundreds of light years, shift direction, accelerate, and even pause in near-perfect unison, defying the expectation that stellar motion should be as unpredictable as a handful of marbles rolling across a tilted table. What makes this synchrony so unsettling is the scale. Normally, stars in a galaxy's disk follow orderly but independent orbits like commuters on a highway, each moving at their own pace, occasionally influenced by local traffic. But here, entire clusters seem to respond to an unseen conductor, their movements mirrored across vast distances. Some pairs reverse course simultaneously, as if connected by an invisible thread. Others accelerate in tandem, their velocities matching down to fractions of a percent, despite having no obvious gravitational link. It's the celestial equivalent of a flock of birds changing direction as one, except there's no flock, just isolated stars moving as though they share a hidden script. So what could orchestrate such precise harmony? The leading theory points to dark matter substructures, invisible rivers of the universe's most elusive substance flowing through the galaxy like underground currents. If these streams are dense enough, their gravitational pull might nudge stars into synchronized paths like leaves caught in the same eddy of a river. Picture a sheet of paper held over a fan. Certain sections flutter in unison, not because they're connected, but because they're responding to the same unseen force. In NGC 1300, these dark matter currents could be the hidden hands guiding the dance. But there's a catch. Some of these synchronized stars lie outside known dark matter hotspots. That's led to a wilder idea: resonant harmonics. Just as sound waves can shatter a wine glass by matching its natural frequency, gravitational waves from ancient black hole mergers or galactic collisions might have left behind standing waves in the fabric of space-time. Stars caught in these ripples could be oscillating in sync, their motions dictated by the galaxy's hidden vibrational modes. It's a cosmic tuning fork scenario where the universe itself rings at frequencies that nudge stars into alignment. Then there's the spine-tingling outlier, coordinated intelligence. Before dismissing it as science fiction, consider that advanced civilizations, should they exist, might manipulate stellar orbits over millennia as part of megastructure projects or energy harvesting. While Occam's razor favors natural explanations, the sheer precision of some synchronies pushes the boundaries of known physics. Could these stars be waypoints in a network we're only beginning to glimpse? The notion seems absurd until you realize nature rarely arranges itself this neatly without cause. Whatever the truth, this celestial synchrony forces us to re-examine how gravity shapes galaxies. If unseen forces can choreograph stars across light years, what other invisible rhythms might govern the cosmos? Every matched orbit in NGC 1300 is a clue, a whisper of order in the apparent chaos. And until we decode the conductor's score, the dance continues, silent and flawless as it has for billions of years. Buried within the torrent of light streaming from NGC 1300, astronomers have detected flashes that shouldn't exist, brief, searing bursts of gamma rays with no apparent source. These aren't the predictable signatures of colliding neutron stars or feeding black holes. They're cosmic ghosts flickering into existence for mere seconds before vanishing without a trace, leaving behind only one burning question: what in the universe could produce such violent energy out of nothingness? The first recorded phantom gamma burst appeared in telescope data as a spike so intense it briefly saturated detectors. A flare packing more energy than our sun emits in 1,000 years, concentrated into a heartbeat of raw radiation. Follow-up scans of the same region revealed nothing: no neutron star merger, no supernova, not even a hint of the usual cosmic wreckage that accompanies gamma-ray events. Just empty space where, by all known physics, something cataclysmic should have occurred. Subsequent bursts followed the same maddening pattern: brilliant, inexplicable, and utterly untethered to any visible celestial object. So what could generate these rogue explosions? One tantalizing possibility involves dark matter's dramatic demise. Certain theoretical particles, like WIMP weakly interacting massive particles, are predicted to annihilate upon collision, converting their mass into pure energy, including gamma rays. If NGC 1300 harbors dense knots of dark matter, their occasional particle collisions might ignite these phantom bursts like cosmic firecrackers. Picture two invisible asteroids smashing together in the void, their crash detectable only by the blinding flash they produce. No debris, no afterglow, just a silent explosion of light. But there's a twist. These gamma bursts don't match the expected distribution of dark matter halos. Their timing and locations seem almost random, lacking the clustering that would signal an invisible structure's influence. That inconsistency has led researchers to an even wilder hypothesis: quantum singularities. Microscopic black holes, leftover relics from the Big Bang, could theoretically drift through galaxies, evaporating explosively due to Hawking radiation. As these pinprick voids finally wink out of existence, they'd release their entire mass as a gamma-ray death cry. It's the ultimate cosmic mic drop, an entire black hole's worth of energy vanishing in a puff of light, leaving no trace behind. Then there's the interstellar lightning rod theory. Some galaxies harbor relic pulsars, dead neutron stars reawakened by freak events, like a rogue planet impact or magnetic upheaval. If NGC 1300 hosts such zombies, their resurrected magnetic fields could generate gamma-ray tsunamis as they realign. Imagine a dormant power grid suddenly surging to life, overloading circuits in a spectacular shower of sparks. Only here, the sparks are gamma flares, and the grid is a stellar corpse light years wide. Yet the most unsettling explanation remains the simplest. We're seeing the aftermath of collisions between objects we've never classified. Could quark stars, hypothetical ultra-dense remnants made of pure quark matter, be smashing together in the galaxy's depths? Or perhaps dark stars, theoretical early universe objects powered by dark matter annihilation, still flicker in isolated pockets, their death throes lighting up the cosmos with gamma-ray farewells we're only now learning to catch. The implications stretch far beyond NGC 1300. If phantom gamma bursts stem from entirely new astrophysical processes, they could represent a hidden layer of cosmic activity, a shadow universe of particle interactions and exotic objects operating beneath our normal observational thresholds. Every unexplained flash is a breadcrumb, a fleeting signpost pointing toward physics we've yet to imagine. And until we solve their riddle, these phantom bursts will keep flashing in the darkness, brief and brilliant as lightning, illuminating nothing but the depth of our own curiosity. Remember those ghostly, fragmented copies of NGC 1300 we called the celestial mirage? The ones that flickered at the edges of our telescopes like reflections in a shattered mirror. Well, hold onto your cosmic hats because the plot just thickened. New observations have peeled back another layer of this mystery, revealing details so strange they've reignited a wild debate. Could these mirages be more than just optical illusions? Could they be glimpses into realities beyond our own? The latest data shows something previous scans missed. The mirage images aren't just distorted, they're subtly wrong. Colors bend in ways gravitational lensing can't explain, with certain wavelengths amplified or suppressed as if filtered through an unseen prism. Even stranger, some of these ghostly duplicates contain structures that don't exist in the original galaxy. Extra spiral arms, phantom star clusters, even entire regions glowing with unfamiliar nebulae. It's like staring at a reflection and seeing a face that isn't yours. Now, the obvious explanation is still some form of exotic lensing. Maybe dark matter's tangled web warps light in ways our models haven't accounted for. Or perhaps NGC 1300 sits at a cosmic crossroads where multiple gravitational lenses overlap, creating a hall of mirrors effect. But here's where it gets mind-bending. Advanced simulations accounting for every known variable still can't reproduce these anomalies. The mismatches aren't just noise, they're systematic, as if the mirages aren't copies at all, but variations. That's where the fringe theories come roaring back. Some physicists argue these discrepancies line up eerily well with predictions from string theory, which suggests our universe might be a four-dimensional brain floating in a higher dimensional space. If another brain, a parallel universe, brushed against ours even briefly, the gravitational interaction could have left imprints in the light like fingerprints on glass. The extra structures in the mirages, maybe they're shadows of galaxies from that other reality, bleeding through the dimensional divide. Then there's the quantum angle. Certain interpretations of quantum mechanics propose that every possible outcome spawns a new universe. Under that framework, these mirages might be fleeting overlaps with NGC 1300's alternate selves versions where its history diverged slightly, leaving it with extra arms or missing clusters. Think of it as cosmic channel surfing, where our telescopes briefly tune into another station on the multiverse dial. Of course, not everyone's ready to jump to parallel dimensions. Skeptics point to more grounded possibilities, like unknown plasma physics in intergalactic space or unusual magnetic fields twisting light in unprecedented ways. Even dust, plain old cosmic dust, could play tricks at these scales if it's structured just right. But here's the kicker: a handful of the Mirage duplicates exhibit time shifts. One shows what looks like NGC 1300 as it might have appeared 100 million years ago. Another hints at a future state with spiral arms stretched thinner from gravitational interactions we've yet to observe. If verified, that's not just lensing. That's a window into the galaxy's timeline, a literal glimpse across epochs. Whether these mirages stem from higher dimensions, quantum echoes, or something we haven't yet imagined, one thing's clear: NGC 1300's reflections aren't just cosmic curiosities. They're stress tests for the boundaries of reality itself. Every anomalous pixel, every mismatched structure is a question, one that might not just reshape our understanding of this galaxy, but of the universe's very fabric. And until we crack the code, these phantom images will keep staring back at us, silent and enigmatic from the edges of the known cosmos. Deep within the radio silence of NGC 1300, an ethereal symphony plays on an endless loop, delicate harmonic waves pulsing through the void with the precision of a cosmic metronome. Astronomers first detected these signals as repeating patterns in low-frequency radio data. Not the usual chaotic static of the universe, but structured oscillations that rise, fall, and overlap like notes in an otherworldly choir. Dubbed the cosmic chorus, these harmonies defy conventional explanations, hovering in the uncanny valley between natural phenomenon and deliberate broadcast. What makes these waves so unsettling is their mathematical purity. Most celestial radio emissions, like the crackle of pulsars or the hiss of interstellar plasma, are noisy, unpredictable. But they carry distinct harmonic ratios, their frequencies aligning with intervals found in musical scales across human cultures. It's as if the galaxy is humming in a key we instinctively recognize, a minor third here, a perfect fifth there, resonating with patterns hardwired into our perception of harmony. So what could possibly compose such a symphony? One compelling theory points to magnetospheric interactions, immense magnetic fields around neutron stars or black holes vibrating like colossal strings. Under the right conditions, plasma waves trapped in these fields could oscillate at harmonic frequencies, creating a natural radio organ. Picture solar winds whistling through a planetary magnetic field, but scaled up to galactic proportions, with entire nebulae acting as resonant chambers. Yet there's a flaw in that elegant explanation. Some harmonic sequences repeat with clockwork precision across years of observations, their timing too exact for known astrophysical processes. That's led to speculation about cosmological feedback loops, regions where energy circulates between stars and gas clouds in self-reinforcing cycles, like sound waves bouncing between walls to create a sustained note. If NGC 1300's unique structure traps and amplifies certain frequencies, it might function as a natural Bose-Einstein condensate for radio waves, filtering chaos into harmony. Then there's the electrifying outlier hypothesis, patterned intent. The signal's harmonic consistency mirrors techniques used in human radio transmission to distinguish artificial signals from background noise. While invoking extraterrestrial origins is a last resort in astronomy, the chorus's structure meets several criteria proposed for identifying potential non-random broadcasts. Could these waves be a beacon, a cosmic SOS, or merely the interstellar equivalent of a child plinking keys on a piano, unintentional yet unmistakably ordered? Here's where the mystery deepens. Recent analysis revealed subdivisions within the harmony's microsecond delays and phase shifts that form nested patterns, like fugues hidden within a larger composition. Natural processes rarely produce such layered complexity without obvious cause. Some researchers suggest this could point to a new class of magnetohydrodynamic phenomena, where turbulence and magnetism interact in ways that compose intricate wave structures. Others whisper about quantum vibrations in spacetime itself, resonating through dimensions we can't yet perceive. The implications resonate far beyond astronomy. If the chorus stems from undiscovered physics, it could revolutionize our understanding of wave propagation in plasma. If it's something else, well, that might redefine humanity's place in the cosmic conversation. For now, the harmonies continue, drifting through the dark, a lullaby without a singer, a song waiting to be deciphered, one haunting note at a time. In the heart of NGC 1300, cosmic candles burn with unnatural endurance, pockets of star formation that refuse to flicker out long after their expected expiration. These are the eternal flames, regions where nursery nebulas continue birthing new stars at rates that defy galactic aging, as if time itself has slowed within their boundaries. While most star-forming regions exhaust their gas within tens of millions of years, these zones have kept their furnaces lit for billions, presenting a paradox that challenges our understanding of how galaxies evolve. What makes these eternal nurseries so extraordinary isn't just their longevity, it's their defiance of the cosmic fuel economy. Star formation is supposed to be a self-limiting process. As young stars ignite, their fierce radiation and stellar winds blast away the surrounding gas, cutting off the raw material needed for future generations. Yet here, the cycle continues unchecked. Spectroscopic analysis reveals these regions are somehow replenishing their hydrogen reservoirs faster than they can be consumed, like a magic pitcher that never empties no matter how much you pour. The secret may lie in an unseen cosmic plumbing system. Some astronomers theorize that dark matter filaments those invisible rivers of the universe's most mysterious substance, are funneling fresh gas into these zones from intergalactic space. Picture an underground aquifer feeding a spring. Only here the water is primordial hydrogen and the pipes are made of gravity itself. These hidden currents could explain how eternal flames maintain their stockpile, continuously injecting new fuel even as stars voraciously devour it. But there's another, even more tantalizing possibility: delayed ignition. Computer simulations suggest these regions might have remained unusually cold and dense during the galaxy's early history, resisting the initial waves of star formation that swept through NGC 1300. Now, as shockwaves from nearby supernova and spiral arm collisions finally reach them, they're experiencing a belated baby boom, like embers flaring to life when a gust of wind hits them just right. The flames aren't eternal per se, they're cosmic late bloomers making up for lost time with a stellar baby boom billions of years in the making. Then there's the wild card magnetic confinement. Recent radio observations reveal these zones are crisscrossed with exceptionally strong magnetic fields, woven into intricate cages that might trap gas against stellar winds. Normally, such fields dissipate as stars form, but here, turbulence from nearby black hole activity or dark matter interactions could be reinforcing them, creating a self-sustaining feedback loop. Imagine trying to blow out a candle inside a wire mesh. The flame persists because the structure shields it from the very forces that should extinguish it. The implications ripple far beyond NGC 1300. If galaxies can harbor pockets of prolonged star formation, it means our cosmic timeline might need rewriting. Perhaps the universe's stellar factories operated longer and in more places than we ever imagined. Or maybe these flames are cosmic aberrations, rare holdouts against the inevitable cooling and quieting of the cosmos. Either way, their enduring glow forces us to reconsider one of astronomy's oldest questions. What keeps the fires of creation burning? For now, the eternal flames keep their secrets, illuminating the galaxy with a stubborn, ageless light. Of all the cosmic riddles NGC 1300 holds, none captivates and confounds astronomers quite like what's been dubbed the Galactic Enigma. an overarching mystery woven through nearly every anomaly we've encountered. It's not a single phenomenon, but a pattern, a thread of inconsistency suggesting this galaxy operates by hidden rules, as if some fundamental law of physics bends or breaks within its spiral arms. From vanishing star clusters to phantom magnetic fields, from echoes that defy causality to celestial choreography with no conductor, NGC 1300 doesn't just challenge our understanding, it taunts it. Take a step back and the enigma crystallizes. Normally, galaxies follow predictable cycles: gas cools, stars form, supernovae explode, recycling material in a rhythm as old as the universe. But here, the rhythm stutters, time delays warp stellar life cycles, magnetic fields tangle without cause, light echoes without explanation. Even the galaxy's rotation seems out of sync with its visible mass, as if an unseen hand nudges its motion. The most unsettling part, these anomalies aren't isolated. They interact. Phantom jets align with twisted magnetic zones. Echo chambers overlap with starless voids. It's as though the galaxy functions as a cosmic Rube Goldberg machine, where one mystery triggers another in a chain we can't yet trace. The leading theory, and it's a stretch, suggests NGC 1300 might be a gravitational oddity, a place where dark matter doesn't just halo the galaxy but infiltrates it, weaving through its spiral arms in dense, invisible filaments. These filaments could act like cosmic puppet strings, tugging stars into synchronized orbits, warping magnetic fields, and even trapping light in loops. Imagine stirring honey into tea and watching it spiral, except the honey is invisible and the spoon is made of something we can't detect. But dark matter alone doesn't explain the creativity of these anomalies. Why would it choreograph stellar dances or cradle starless voids? That's where fringe ideas creep in. Could NGC 1300 be a collision site between universes, a cosmic bruise where the laws of physics fray? Some theorists point to the Mirages, those warped reflections of the galaxy, as potential shadows of a parallel brain brushing against ours, its gravity imprinting distortions onto our reality. Others whisper about time anomalies, where regions of the galaxy experience time at different rates, explaining delayed supernovae and ancient stars in young neighborhoods. And then there's the silence. The galaxy's supermassive black hole, which should roar with energy, sits hushed. Its quietude might be the linchpin. If it's not feeding, it's not ejecting energy to disrupt the galaxy's quirks. Like a skipped beat in a song, its absence lets the anomalies persist, unchallenged by the usual chaos of an active core. The galactic enigma isn't just a collection of puzzles, it's a mirror. Every unexplained flicker, every untethered motion reflects how much we don't know about the universe. NGC 1300 could be a cosmic outlier, a freak of nature. Or it could be a preview, showing us the limits of our current physics and hinting at discoveries waiting just beyond our grasp. One thing's certain, the deeper we look, the clearer it becomes that this galaxy isn't playing by the rules. Whether it's rewriting them or simply revealing how little we've understood all along, NGC 1300 stands as a humbling reminder. The universe is stranger, far stranger than we've dared to imagine. And somewhere in its swirling mysteries lies a truth that could change everything. From phantom spiral arms flickering in and out of existence to a supermassive black hole that refuses to roar, from star clusters that vanish without a trace to eerie radio signals pulsing like cosmic Morse code, NGC 1300 isn't just a galaxy. It's a rebellion against the textbooks, a swirling masterpiece of cosmic anomalies that dares us to rethink everything we thought we knew about the universe. Over 30 bizarre phenomena call this galaxy home, each one a puzzle piece in a grander mystery. There's the time-delayed supernova that detonated hundreds of thousands of years late, the starless void where light itself seems to vanish, and the celestial echoes that bounce back as if space itself has a memory. Magnetic fields twist into knots without cause, dark matter deserts defy galactic logic, and ancient stars burn where they shouldn't exist. But here's the real wonder: none of these mysteries exist in isolation. They're threads in a tapestry so intricate, so interconnected, that studying one anomaly often leads straight to another. The galaxy's unstable central bar wobbles in sync with its phantom jet. The cosmic whispers of radio signals overlap with regions where stars move in uncanny unison. It's as if NGC 1300 is a locked puzzle box where solving one riddle only reveals 3 more beneath it. And that's the beauty of this cosmic enigma. It doesn't just challenge our knowledge, it exposes how much we don't know. So which of these phenomena captivates you the most? Is it the ghostly X-ray sources that flare and vanish like cosmic will-o'-the wisps, the mirage reflections that just might hint at parallel universes? Or the eerie synchrony of stars moving as if choreographed by invisible hands? Every anomaly in NGC 1300 is a doorway, a chance to ask bigger questions. What if dark matter isn't what we think? What if black holes have hidden states we've yet to imagine? What if the laws of physics aren't universal, but bend in the corners of galaxies like this one? This galaxy is more than a collection of oddities. It's a reminder that the universe thrives on surprise. Just when we think we've mapped the edges of understanding, places like NGC 1300 whisper, "Look closer." Dig deeper. The wildest discoveries aren't behind us, they're waiting in the shadows of the cosmos, just beyond the light of our telescopes, so stay curious. Keep questioning, and remember, the next great cosmic revelation might already be hiding in plain sight, tangled in the spirals of a galaxy that refuses to play by the rules. The universe is stranger than fiction, and it's not done surprising us.